Hello everyone, this is Mr. Osama. Today inshallah we are going to talk about some exercises for the mid-segments of the triangles, Chapter 5, Lesson 1, Grade 8 Geometry. We had the definition of the theorem before and we got the definition of the mid-segment within triangles, which is any segment that joins two midpoints of any two sides of the triangle. And this is mid-segments always parallel to the third side, which is the base of the triangle, and equal its half length. Today we are going to focus on the properties of the mid-segments and how to use these properties for solving the exercise. We need to get back to the definition again to make it easy for you. So I'm gonna draw a regular triangle here. For example, triangle A and B, AB and C. I'm gonna draw a triangle ABC, triangle ABC, ABC. I have a midpoint for AC is gonna be X. Midpoint of BC is Y. When you line up the 2 points, it will be the mid-segment, which is XY. This is mid-segment, which is XY, have two properties, which is parallel to the AB and equal its half of length. So I'm gonna remark a little bit. This is mid-segment here. So I can say that the segment XY is the mid-segment of the triangle. The mid-segment of the triangle ABC. The conclusion right away that XY parallel to AB segment, which is the third side, and half of its length. So XY equals 1/2 AB length. And this is the conclusion of the mid-segments theorem. So we need to apply these two conclusion on some exercises. So I'm gonna start off with exercises. For that, I'm gonna do some exercises with the theorem here right now. So in the front view, I have given triangle ABC. The question asked me to use the triangle mid-segment theorem to name parts of the figure for the exercise from 1 to 5. So I'm gonna start off with the kinematical condition of the figure. ABC is a triangle, D is a midpoint of AB, E is a midpoint of BC. Then DE will be the mid-segment of the triangle ABC. We need to complete the following exercise. The first one, a mid-segment of triangle BC, so I have to name the mid-segment name, which is the DE. The DE segment will be the mid-segment. The second question is the segment parallel to AC. According to the definition of the mid-segment of the triangle, DE will be the mid-segment in the triangle ABC, so it's gonna be DE parallel to AC. So I'm gonna write down again DE is parallel to AC, which is the third side. Question number 3, a segment that has the same length as BD. We'll get back to the kinematical condition of the triangle ABC, that D is a midpoint of the segment AB. What does it mean? It means that the AD equal to BD. So I'm gonna say BD equals to AD segment. So I'm gonna write down here AD. Question number 4 states that a segment that has half the length of AC, the segment that has half the length of AC, supposed to be the mid-segment, because this is one of the conclusion of the mid-segment theorem, that this mid-segment is always parallel to the third side and equal its half length. So it's gonna be DE again. DE would be the segment that equals half the length of AC. Have the length of AC. So right now we got question number 4, the segment that has the half length of AC is gonna be D again. Question number 5, a segment that has twice the length of AC. Get back to the kinematical condition of the triangle ABC, or the figure in general. Point E is a midpoint of BC. What does it mean? It means that AC equal to EB, which is EC is half of BC, or BC is twice as much as EC. So I'm gonna say the answer for question number 5 would be BC. BC will be the segment that has twice much as AC. So BC is 2 times AC. This will complete the answer for question number 5. We need to move to the next question, which is question number 6, from 6 to 13. The second type of question here. The question states that complete the exercise from 6 to 13. Show that the midsegment GH is parallel to DF and GH equals 1/2 or 1/2 DF, 1/2 DF. Here in the given figure, he gave me the coordinates of the points. The point D is 0 and 0, point F 6 and 0, the point E is 0 and 4, and point G is midpoint. No, it's not. It's a midpoint for ED, and H is the midpoint of EF. We need to use the mathematical formulas for the midpoints to find out the coordinates of the given points, which is G and H. We have to get back to the midpoint formula. So I'm going to get back to the midpoint formula. I'm going to move up a little bit here. What is the midpoint formula? So I need to write down the midpoint mathematical formula. The midpoint for the any point, say that I have a segment AB. This segment has a midpoint M. This is point has a coordinates x2, y2, and A has a midpoint x1, y1, and the midpoint has a coordinate x and y. How to get the x coordinates for the midpoint and y coordinates? X coordinates will be the sum of x1 plus x2 over 2, and the y coordinates for the midpoint will be the same, which is y1 plus y2 over 2. We need to use this formula to find out the coordinates of the questions related to the given figure. So I'm going to get back here. Question number 6, use the midpoint formula to find out the coordinates of G. So I have to find out the border of the segment ED, which is 0, 4, 0, 0. So I need to find out the G coordinates. The G coordinates will be to find G XY coordinates. X will be, I need to get back to the figure. The X will be 0 plus 0 over 2. So 0 plus 0 over 2 will be 0. And the Y coordinates for the same point will be, get back to the figure, which is 4 plus 0 over 2. 4 plus 0 over 2 will be 2. So the coordinates of the G is going to be 0 and 2. It's going to be 0 and 2. So G will be, the coordinates of G will be 0 and 2. So I have to get back to the figure here to write down the coordinates of the point G according to the formula 0 and 2. We'll do the same thing with question number 7, which states that use the midpoint formula to find out the coordinates of H. So I have to find out the coordinates of H. I'm going to move up a little bit here to find the coordinates of H. To find H coordinates, which is X and Y. X will be the sum of the coordinates of the X's, which is 0 plus 6 is going to be 0 plus 6 over 2, so it's going to be 6 over 2, which is 3. The Y coordinates for the same point, I'm going to get back, so it's going to be 4 plus 0 over 2, 4 plus 0 over 2, so it's going to be 4 over 2, it will be 2. So the final result will be 3 and 2 for H. H will be 3 and 2. H will be 3 and 2 coordinates. So I have to get back to here and write down 3 and 2. 3 coordinates for X and 2 for Y. So I used the midpoint formula to find out the coordinates of the midpoints, which is G and H. So G and H, the G 0 and 2, and H will be 3 and 2. We need to move to the next question, which is question number 8. Use the slope formula to find out the slope of the DF. How to find out the slope by using the mathematical formula? The slope formula is the changing in y over changing in x. I have to write down the slope formula. So I'm gonna get back here. Slope formula. I'm gonna write down the slope formula here. Slope can be obtained by slope equals y2 minus y1, y2 minus y1 over x2 minus x1. This is for any point. So I'm gonna get the slope for the segment according to question number 8 for the segment DF. DF which has the borders 0, 0 and 6 and 0. So the y's will be 0 minus 0, so it's going to be 0 minus 0 over 0 minus 6, so it's going to be 0 over negative 6, which is 0. This is for the slope of the first segment. So the segment DF has a slope 0, so I have to write down here the slope of this is DF is going to be 0. According to the slope formula which we had right now. Next question, use the slope formula to find out the slope of GH. GH, we need to get back to the mathematical formula here. So I'm going to write down here the slope of GH. Slope of GH segment will be y2 minus y1 over x2 minus x1. Get back to the coordinates of the formula is going to be for the 2 minus 2 over 0 minus 3, so it's going to be 0 over negative 3, which is 0, so the slope will be 0. Slope equal 0. Back again to the question number 9. We need to write down the slope here, so it's going to be 0. I got the slope of the segment DF and the slope of the segment GH are equals, and we had this is before that if two segments are equal in the slope, that means they are parallel. If two lines or two segments have the same slope, what does it mean? It means that the two segments or two lines are parallel. So this will complete the answer on question number 10, that DF and GH are parallel. I have to say yes here. Yes. Question number 11, use the distance formula to find out DF. So I need to get back to the distance formula. So I'm going to write down the distance formula here. Distance formula D equals for any segment. D equals square root of x2 minus x1 powered by 2 plus y2 minus y1 powered by 2. This is the distance formula, so I have to apply this formula on the first segment, which is required. DF segment, so I have to use the distance formula for that. So I'm gonna say for the x's is gonna be 6 minus 0, so D will be 6 minus 0 for the x's power 2 plus 0 minus 0 for the y's power 2. So it's D equals square root of 36, which is 6 units. So it's gonna be 6 units. So I have to write down here for question number 11, the distance for DF will be 6 units. Next question, which is question number 12, is the distance formula to find out the GH. So I have to use the distance formula again. So I'm gonna move up a little bit. D will be, I'm gonna write down the distance formula D equals the square root of x2 minus x1 power 2 plus y2 minus y1 power 2. Back again to the question, I have to go through the 2 points, which is G and H. So I'm gonna say for the x's will be 3 minus 0 power 2. D equals square root of 3 minus 0 power 2 plus 0 minus 0 power 2, I'm sorry, 2 minus 2, 2 minus 2, sorry, so I have to cancel out this. 2 minus 2 bar 2, 2 minus 2 bar 2, so I'm gonna write down here 2 minus 2 bar 2, so D will be square root of 9 plus 0, which is square root of 9, which is 3 units. So this will complete the answer for question number 12, which is 3 units. 3 units. Last question, does GH equal 1/2 DF? Yes, because this is 6 and this is 3, so this will complete the properties of the mid-segment. So I have to write down here yes, and this will complete the answer for the question number 13. From question number 10 and question number 13, this will complete the properties of the mid-segments, that the mid-segments has two properties. The first one, parallel to the third side. The second one, half of its length, and this will complete the application of the mid-segments theorem. You guys, I think you have understand everything we've been through right now. I hope you got understand what we've been through, and inshallah I'm gonna meet you in another video. Thank you for watching this video, and inshallah we'll meet again. Be good and stay perfect. Thank you and have a good day. Goodbye.